So this week we're going to work on independent and dependent events. Two events are independent when the occurrence of one has no effect on the occurrence of the other. For instance, rolling a total of 12 with two six-sided dice has no effect on the outcome of the future rolls of the dice. To find the probability of two independent events will occur, multiply the probabilities of each together. So here's an example. It says a coin is tossed and a six-sided dice is rolled. Find the probability of getting a head on the coin and a six on the dice. Well, head on the coin, that is just going to be 1/2, right? Oops, let's change my marker here. So that's going to be 1/2. And a six-sided die is rolled, probability of getting six on the die, well, that's 1 out of 6. So the probability that both are going to occur is 1 out of 12. We just multiply the two probabilities together. When you multiply, you just multiply across. So our answer would just be 1 out of 12. A jar of marbles contains 4 blue marbles, 5 red marbles, 1 green marble, and 2 black marbles. A marble is chosen at random from the jar. After replacing it, a second marble is chosen. Find the probability for the following. So find the probability that you get a green and then a red. Well, probability of green is 1 out of 12. And then we're going to put the green one back in. And then the probability of a red one, well, that's 5 out of 12. So we multiply that together, we end up with 5 over 144. That's not a really good probability, is it? I mean, that's pretty small. How about a blue and then a black? Well, we got 4 out of 12 times black, that's 2 out of 12. So that gives me 8 out of 144. Now, we're going to talk about dependent events. Let's say I had this problem and I said, let's go probability of a green and then a red, but we don't replace it, okay? So that would be called dependent probability if we don't replace, because the effect that the first thing is going to affect the second. So the probability of a green would be the same, it'd be 1 out of 12, but now the green marble's not there, it's gone. So what's the probability of getting a red one? Well, that's 5 out of 11. There's only 11 marbles left. So that is dependent probability. So if you put it back in, the second draw is not going to affect the second draw doesn't affect the first draw, but if you don't put it back in, it sure does. So that's our second thing that we're going to do this week is dependent probability. Two events are dependent if the outcome or occurrence of the first affects the outcome or occurrence of the second, so that the probability is changed. So here's an example. Let's say we have 2 cards have been drawn from the deck of 52 cards without replacing the first one. First one, black. Find the probability of getting the first card as a king and the second card as a queen. Well, if I draw, I know there's 52 cards in here. There's 4 kings, so it would be 4 out of 54 times, and then a queen, well, there's 4 queens. I'm sorry, there's only 3. I don't know what no, there should be 4 because there's a queen, king, there's 4 queens because there's a heart, a diamond, a club, and a spade. And then now to get a queen, there's 4 queens, but there's only 53 cards left. So this would be my probability if what am I doing? There's only 52 cards. Boy, I'm really messing this problem up. So the first, to get a king, I'd have 4 out of 52. I don't even know how to write 52. 4 out of 52 times. And then to get a queen, there's still 4 queens there, but there's only 51 cards left. So that, if I multiply that out, that would be my probability. Now, when you have big numbers like this, you really should reduce. Like this would be 1 out of 13. I don't think this reduces down. I don't think so. So I'd have 4 over 51, and then I can multiply this out. But dependent means that the first is going to affect the second. So in this problem, it says, find the probability for the experiment of drawing 2 marbles without replacement from a bag containing 4 green. Okay, so I'm just going to write this down. Green, 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 green. 6 yellow. 1, 2, 3, 4, 5, 6. 5 red. 1, 2, 3, 4, 5. So there's 4, 10, there's 15 marbles total. And then what is the probability that the marbles are different colors? I think we would work on this one. Different colors, because then this one, let's cross this one out, because I would not ask you that one, because different colors, that's a whole different ball game when you're trying to talk about things. Now let's just change this and say, what is the probability of getting a green then a yellow? Okay, so the probability of getting a green is going to be 4 out of 15. But now one of those greens is gone. And then the yellow, I have 6, so this would be 6 out of 14. I'm going to simplify this down. 2 goes into 4 2 times, 2 goes into 14 7 times, 3 goes into 6 2 times, 3 goes into 15 5 times. So 4 over 35 would be my answer. All right, so dependent events means that one of the second, when you take the probabilities, the second event is going to be affected by the first one. So in this problem, it says find the probability for the experiment drawing 2 marbles without replacement from a bag, 3 green. So I'm going to draw this out again. 3 green, 6 yellow, 1, 2, 3, 4, 5, 6, and 4 red. 1, 2, 3, 4. So that's what, 13 marbles? That both marbles are yellow. Okay, so probability of getting a yellow on the first one is going to be 6 out of 13. Now there's only 12 marbles left, but there's only 5 yellow ones, so that would be 6 over 13 times 5 over 12. I'm going to reduce that down, so that'd be 5 over 26, if my math is correct, and sometimes it is. All right, that is it for this week. I hope to see everybody on Monday for the main lesson. You guys have a great week. Bye.